Hello friends, welcome to my YouTube channel. Today we will learn the concept of Merozygotes in Lactose Operon system. I'm not going too much deeply about the concept of lactose operon as well as its regulation in E. coli cells, but it is related to lactose metabolism, and it is a cluster of three different genes that are X, Y and Z, and these three genes are responsible for the conversion of lactose into glucose as well as galactose. So in normal state, E. coli cell contains two types of DNA, right? One is chromosomal DNA and other is extra chromosomal version of DNA. And lac genes are present in the single copy at their chromosomal region. So this is the haploid state of E. coli cell. But E. coli cells contain a fertility plasmids, and these fertility plasmids are present in two forms, sometimes F plus form and sometimes F dash form. If F dash form is present in some strain of E. coli while we are culturing E. coli cells, then F dash plasmid contain extra chromosomal DNA integrated with some part of chromosomal DNA. So there are chances that in E. coli cells some genes are present in their diploid copy. So when these diploid genes are present in F dash plasmid and such type of cells are dividing via binary fission, then via the formation of pilus, this F dash factor is also transferred to the newly formed daughter cells, and this daughter cells again contains two copies of lac genes, and this is particularly a diploid or a partially diploid state, or we can say that it is a merozygote state of E. coli cells in Lactose Operon system. So in the next video we will learn when Lactose Operon is expressed different mutations in their regulatory as well as operator regions, then what will happen with their haploid as well as merozygote state. So please keep watching, like, subscribe and share. Thank you. Have a nice day.